Welcome back, everyone. Today, we continue on in our Intro to Reduce series. Today's lesson will be covering a common interview question. Given a string, write a function to determine if it is a palindrome. That is to say, is the word spelled the same backward as it is forward, such as Bob or race car? Now, this won't be the most optimal solution, but I thought this would be a good case to show the other parameters you can accept in your reducing function and also stretch your imagination as to what reduce can actually be used for. So the prerequisites for this video will be a bit different. I'd like you to have at least watched my video entitled Implement Logical Operators Using Reduce, as this video will make use of the same concepts we explored in that video. I'll be sure to link to that video in the description. So before we start, let's think about how to solve this problem conceptually. This gives us the advantage of thinking about the problem, about the actual problem, and not getting mired in the details of code. So let's write an example of a palindrome. Since we're using reduce, I'm going to write it as an array of characters. Now, when I'm trying to solve problems, I'll try to use a simple example first, just to keep the context low in my head. So let's do that now. So what does it mean for something to be spelled the same forward as it is backward? Well, let's think about that. That would have to mean that the beginning character was equal to the character at the end, and the second character would have to be equal to the character at the end offset by 1. And it seems like we've uncovered a pattern. So in our example, the B in Bob, the first one would have to be equal to the character in the opposite position, which is also B. And O would have to be equal to the character in the opposite position, which is itself. And something is always equal to itself because of identity. Okay, so it seems like we're going to have a way to keep track of characters going forward as well as characters going backward. Or to put it another way, we need to traverse the array from left to right and a way to traverse the array from right to left. So it seems like we can do this with 2 pointers. As one increments, the other will decrement. Then we can compare the values in the array at those indices, and we can carry the result of that comparison through to the next operation. So the forward pointer will start at 0, the beginning of the array, then 1, and then 2. The backward pointer will start at 2, the end of the array, then 1, and then 0. Each time through, we'll compare the character at both indices. Now, there's 2 cases where we would want to short circuit the iteration here. One case is that if we compare 2 characters and we get false, then it's not a palindrome. It doesn't matter how many more characters we check, right? The other reason is if we make it past the halfway point in the array and we've already compared each pair of characters, we'll already know if we have a palindrome or not. There's no reason to check them again. Well, since we're using reduce, we can't really short circuit the iteration. Actually, I'm lying to you. You can do that, but it involves mutating the original array, which is almost always bad practice, so we won't do it. As I said though previously, this is not an optimal solution. It's meant to illustrate another use of reduce. So let's go ahead and set this function up. So we know that we need this to be an array, so let's convert it to an array now using the split method on the string prototype. The delimiter will be an empty string, so we're just going to get an array of characters back, and then we can call reduce on the array. Okay, so before we talk about the reducing function, let's talk about the accumulator. If you've been following along, I've said in past videos that we can determine our accumulator based on the data type of our expected output, which is a Boolean. But which Boolean? Well, let's think back to our problem. We wanted to make sure that all comparisons of each character pair, basically each character and its opposite in the array, are valid. Well, that sounds a lot like the logical operator AND we worked on in our last video. And in that video, we said that the identity element for Booleans under conjunction is true, so that we can use that. We'll come back to how that fits in a minute. Okay, let's scaffold out the big pieces of our reducing function using the pattern we've been establishing in prior videos. So up until now, we've been using ACK, short for accumulator, and val, short for value, or current value, if that helps you. But we actually have other parameters we can accept as part of this reducing function. So we'll have access to the index as well as the entire array we're iterating over. Let's write that in now. So instead of val, let's rename that to char. Is it char or car? I can never remember. It's short for character, anyways. You can always rename these, by the way, to something that makes more sense for you. I just like having a pattern, so it's almost like a stub, and then I can change what I need to if it makes more sense. Okay, let's go ahead and do that now. Okay, so we know that we're going to have to compare each character with its opposite in the array, and that's going to return a Boolean, right? Because when we do comparisons, it's an equivalence relation, so we're going to get a Boolean back. But we're going to get to that in a second. We also need to be able to return a new accumulator, which will also be a Boolean, by comparing the previous result with the current comparison. So the previous result, remember, is going to be stored in the accumulator. So let's start there. So let's review what's going on here for a second. Remember, each iteration, we're going to check to see if both the previous result, ACK, and the current comparison are both true. The result of that is passed in as the new accumulator. It's like the notion of carry in addition that I've noted in previous videos. So now how do we compare the characters? We said that we would need both a forward moving and backward moving pointer. So what could we use for that? Go ahead and pause the video if you want to take a crack at it, and I'll wait. Okay, so sometimes I have to ask myself, what do I have access to, and what can I introduce? When looking at something you have access to, don't just ask, what is this thing used for? Also ask, what could I use this for? The former can kind of box you into a way of thinking that excludes other possibilities. For example, if you're given a hammer, all you see is something to hammer nails. But if you look at the hammer and ask, what could I use this for? Then you've created your first slasher movie. All right, so it looks like I have access to the index here as I and the whole array. Well, I will be our forward moving index. It will always be equal to the current index you're on. But we can use this to our advantage. At first, I is equal to 0, and we want to compare the character at that index to the character at the end of the array. We can find the last character in the array by using the length of the array we're iterating over, and we have access to that here in the reducing function. But we'll have to subtract 1 from it, because arrays are zero-based indexed. Let's go ahead and do that now. Okay, so that will get the last character. But wait, we don't just need to get the last character, we need to get the last character and then the second to last character, etc., etc. It needs to be moving backward. So in order to move the needle, what else do we need to know is moving? That's right, our forward index is incrementing by 1. So we can use that to move our backward index further and further back, traversing from the end to the beginning of the array. So this whole thing right here, this is our backward index. Okay, so let's give this function a try and make sure that it works. Okay, very nice. So we can refactor this to use some intermediate variables and maybe give you a further intuition about what's going on. Okay, looks like that worked. Let me go ahead and close this. So we have our backward index here, and we're using that to access the character in the opposite position as the character we're currently on. And then we check to see if the previous comparisons and the current one are all true. Remember, the previous comparisons get rolled up into this accumulator, and we're constantly checking on the current comparison. Okay, well, we made it. We had to put our thinking caps on today, and we used reduce for this. Again, this is not the most optimal solution. You could have used filter for this. A more optimal solution would be to use like a for loop and short circuit, like we talked about before. But This is an intro to Reduce series, and we're going to keep using Reduce to do more and more things so that at the end of this, you should have a wealth of examples and things that you've built and have a better intuition for how Reduce works under the hood. So hopefully the video is not too long. It feels like it's pretty old right now, probably old enough to vote. So I'm going to go ahead and end it right here. So yeah, as always, if you have any questions, feel free to leave me a comment below. And if you like the video, please consider subscribing, liking, and hitting that bell icon. Thanks, everyone.